Okay, let's go over quiz 4 solution. So the first question is find the limit, right? So part A, I want you to find the limits when x go to infinity of 1 over x, and for B, the limit when x go to negative infinity of 1 over x. So here, we have the same function, so we just want to find the value when x approaches infinity and negative infinity. So remember, when x is approaching to a very big number, so 1 divided by a very huge number is going to be equal to 0. The same thing here, when x is going to a very negative huge number, 1 over that big negative number is going to be equal to 0 too. So if you want to explain this, you can also draw the function on the xy plane, and this is xy, and if you draw the function 1 over x, the function is going to be look like this. So here is 1 over x. If you graph this on xy plane, and as you see, if x is going to infinity, right, your function is approaching 0, which is correct here. The same thing if x is going all the way to negative infinity, your function is also approaching 0 too. So you can draw the graph, and this is enough to explain your answer. Okay, let's go to part C. So part C, limit when x go to infinity of 3x squared minus x minus 2 over 5x squared plus 4x plus 1. Now we have the limit of infinity again, but this time is a fraction, is a rational function. So the answer for the rational function is if the numerator and the denominator have the same degree. So on the top we have second degree, on the bottom we also have the second degree. Then when x going to infinity, the value of your limit should be the coefficient of the top divided by the coefficient of the bottom, which is 3 over 5. That is shortcut. Now, but if you want to explain this, remember we have to divide both the bottom and the top by the largest degree, right? So in this case, the largest degree of the bottom is the x squared. So we have to divide x squared by the bottom and the top together. So let's try that. Limit when x go to infinity. Now the largest degree at the bottom is x squared, so we have to divide that by the top and the bottom. So divide the bottom by x squared, right? Divide by x squared. Do the same thing to the top. This is 3x squared minus x minus 2 divided by x squared. Okay, that's gonna give you x squared and x squared gone, give you only 3, right? X and x give you minus 1 over x and minus 2 over x squared. The bottom, x and x are gone, give you 5. X and x cancel, give you 4 over x and plus 1 over x squared. Now when x go to infinity, this term is equal to 0, right? Because 1 divided by a very huge number is 0. The same thing to here, 0, 0, 0. You have 3 over 5, which is this answer. Part C, the last part of question 1. Part D, limit when x go to negative infinity of x squared plus 1 and minus x. Okay, so we don't have a rational function in this case. We cannot do the division as we did in the previous question. Now, but if you think about this one, when x go to a very negative, huge number, remember we have negative here. If you plug into this one, right, negative and negative become something positive. So very large number. Okay, so again, negative, when you plug in the x squared, square of a negative give you positive 1, right? And then positive 1 plus 1, this whole thing should become also something very huge, right? Because infinity plus 1 is just infinity, very huge number. When you take the square root of a very huge number, it's still something infinity, something very big, right? And then you add to this again. So the whole thing, when you add infinity to infinity, they are always big or infinity, right? So by the end, your limit is just infinity. You plug in directly. You can explain this way. So negative, when you get to x squared, it's become positive 1. And positive plus 1 is just very big number. You take the square root of something big, it still gives you infinity. Then you add to infinity, which is something also huge, or the final answer is infinity. So that's a quick way to explain your answer. Okay, second question. So for this question, I want you to find an equation of a tangent line. Okay, the tangent line to the parabola y equals x squared as the point 1 and 1. Remember, the equation of a tangent line to this function, and they give you 1 point here. So from your previous class, if you want to find the equation of the line, you have the point slope formula y minus y0 equal m x minus x0. In this case, this is x0, this is y0, right? So all we have to do is we need to find the slope. Okay, the slope m. Now, the slope of the tangent line is what? The slope of the tangent line is the derivative of the tangent line at that point here. Okay, so you want to find the tangent line to this function. We just have to find the derivative of this function at this point. That's equal to the slope of the tangent line. Now remember the formula. We have two different formulas. So one, the slope is when limit x go to a, f of x minus f of a over x minus a. Or the other one, m equal limit when h go to 0, f of h plus a minus f of a over h. So if you use these two limit definition, you can find the slope. The slope is the limit of these two quotients. So if you use this one, make sure you have the h go to 0 and divide by h. Or you can use this formula, right? F of x minus f of a, x a. So remember here, x minus a, x minus a, x go to a. So this is a way to remember this. So I can use either of these two formulas to find the slope for this function at this point to give you the slope of the tangent line. So we use this a lot in the class. So how about let's try this one this time. Either way, you still have the same answer. Okay. So f of x in this case is this function, right? The function that we are trying to find the slope of that point. Now, limit a we are trying to find when x approaching 1, right? Because x0 is 1. So x in this case is 1. I mean a in this case 1. So x is trying to approach to a or 1. So here is a. x0 is also the a in this formula. So when x is trying to go to 1, f of x, which is this function, or x squared, right, minus f of a, which is f of a is 1, so f of 1, over x minus a is 1, right? So that's going to be equal to the limit when x go to 1, f of 1, if you plug in 1 for x, 1 square give you 1. So x squared minus 1 over x minus 1. Then we can factor the top. So x squared minus 1 is the difference of the square, or x minus 1, x plus 1. You can factor out into these two factors. And then x minus 1 at bottom. X minus 1 and 1 cancel. You're going to have limit when x go to 1 of x plus 1. Now you can just plug in directly x equal 1, which is 1 plus 1 or 2. So 2 is your slope in this formula. Okay, so if I rewrite this one, I have what? Y minus y0 or 1 equal m is 2, x minus x0 is 1. Now I move the 1 to the right hand side. Y equal 2x minus, do the distribution, right? 2 times minus 1 is minus 2, and then plus 1 to the right. That's gonna give you y equal 2x minus 1. That is your equation of the tangent line to this function at this point. Now the last question. This is a very famous, popular question about the limit and velocity and stuff. Okay. So this question, I said that I drop a ball on the top of a building that is 450 meters. Right. This is the route. This is the ball. So I drop it down to the route. Now I have the position function, right, equal 4.9 t squared. This is the position function. T is in second, and this one is the position function of the ball in meter. Okay, comparing to the route. Now part A, I want to find the velocity of the ball when after 5 seconds. So after 5 seconds, what is the velocity? Okay, so what I all have here is the position function. So you have to remember, if I have a position function, right, or your location of something, of the object. Now, if I take the derivative of the position function, I should get the velocity function. Okay, because the position function is in meter, right? When I take the derivative, I take the meter with respect to the time. That means meter per second, which is the velocity function. Now, I take one more derivative of the velocity function. That means I take meter per second with respect to the time, which is per second one more time. So meter per second square, or I will get the acceleration function. Okay, so your original function is position function. If you take the derivative of that, you get the velocity function. You take one more derivative of the velocity function, you get acceleration function. Now we are given the position function. but we want to find the velocity after 5 seconds. So this is the position function, not the velocity. So you cannot plug in phi directly to here to find your position function. We have to take the derivative of this function. Then we can plug in phi too. So how do I find the velocity function of this position function first? The way that you do this is, remember, we have f prime of x equal to limit when h go to 0, right? F of h plus a, x plus x in this case, because we are talking about x, minus f of x over h, right? So we can call this, maybe this is the f function, right? So it's matched with this formula, so we can plug in. Now in this case, we are trying to find the position function, I mean the velocity function, and the variable should be the time, so that we are trying to find the time to match with this one. So here, if we use this limit definition, right, or to make it easier, you can rewrite this one. I can say that f of t, because we are trying to find the time t to match with this given function. So f of t equal f prime of t equal f h plus t minus f of t over h. So that now we are matching with this t variable here. So this is the derivative of your position function. Okay, so now let's try to find that first. Then you can plug in phi to the t and find the velocity, because we need the velocity function first before we can plug in phi, and the velocity function is just the derivative of your position function. Okay, so that makes sense. Let's move on. So f of h plus t. Okay, we know that f of t is equal to 4.9 t squared. So f of h plus t, you take this whole thing inside the parenthesis here. You take this whole thing, plug into the place of t to get the value of f of h plus t. So that's going to be equal to 4.9 t squared. T now become this whole thing. So h plus t, and then the whole thing squared, minus f of t, and f of t just this one we already have. So 4.9 t squared over h. Don't forget that the limit is still h going to 0. Now the second thing is you have to simplify this fraction. So first expand this binomial. So 4.9, this become h squared plus 2 times h times t, which is 2ht plus t squared, and then minus 4.9 t squared over h. We're trying to find the factor h on the top, so we can cancel that at the bottom, so we can plug in h without having to divide by 0 at the bottom. If you do the distribution here, here, and here, you will get 4.9 h squared plus 9.8 ht, and then plus 4.9 t squared, and then minus 4.9, and then over h. Okay, and 4.9 t squared minus and plus, that's gone, right? They cancel each other. And if we only have this left, right? Now we can factor out the h term. So limit still h go to 0, factor out the h. You have 4.9 h plus 9.8 t, and then over h. Now you can see we can cancel the h. So if h go to 0 for this remaining factor, this term has the h, so let's go to 0, right? Because 4.9 times 0 is 0. So the only thing we have left is 9.8t, because t is not 0, because we only have h equal to 0. So the rest we have is 9.8 t. That is your velocity function. This is f prime of t equal to 9.8 t. So we have f prime of t equal 9.8 t. We are trying to find the velocity. This is your velocity function, right? So we're gonna find at the time t equal 5. So I will just plug in 5 to here. F prime of 5, that will give you 9.8 times 5, and this is approximately equal to 49 meters per second. Okay, the second part is asking for how fast the ball traveling when it hit the round. Okay, so we are trying to find the speed or the velocity of the ball when it hit the round. Now we have the velocity function, but we don't know the time t when the ball hit the round. If we know the time t when the ball hit the round, we can just plug into this velocity function and we can find the speed, how fast of that. So we got stuck there. But we need to figure out a way to get the time when, after how many seconds after we drop the ball, then it hit the round. We know that we have the position function f of t equal 4.9 t squared, right? This is your position function. Remember, the tower, the whole thing is 450 meters. So your position function starts from here. If the ball hit the round, it must travel a distance of 450 meters. So you can set this position function equal to 450. Then we can solve for the time t that make your ball travel 450 meters, which means it's hitting the round. So now here we can solve for the time t. If I divide both sides by 4.9, I get 450 over 4.9. Then we take the square root of t. We only take the positive value because the timing is always positive. So take the square root of this. It's going to be equal to approximately 9.6 seconds. So after 9.6 seconds, the ball is hitting the round here. Now we have the time. We have the velocity function here. I can just plug in this time to here to find the speed. So f prime of 9.6 when it hit the round is going to equal to 9.8 from here. T is 9.6, and this gives you around 94 meters per second. Yes, that's 94 meters per second. So this speed is faster than as the point time equal 5 seconds, which is only 49 meters per second.